Okay, so good evening, everyone. I'm hoping we are all fine. Yeah, so the question we're looking at, that is B2 in our chemistry 2020 paper. It has to do with what we call a chromatogram. Yeah, so that's the kind of a question we're looking at this evening. So I hope we are all updated on how we are moving. So let's talk of that's science, chemistry, 2020. Yeah. Okay. So we are. Let's talk of. Let's talk about chromatography. Okay. So chromatography. This is a technique that is used to separate mixtures of solutes using a solvent and a separating medium. So now, if you have two solutions that are mixed up together, and then you need to separate them, we will look at critically look at separation techniques. There is when we are separating sand from water. Okay, Chirufia, you are welcome. So when we are separating sand from water, we use a funnel. So just like the way you filter tea in the morning, like those that use masamba ya jaya, like yamuka paper you put in the water and then you boil the water and then you get a tea strainer and then you strain the what's this the tea. So vijavavi masala pamwamba, the residue and the like. So those are separation techniques that we use. For salt, if salt is mixed in water, we simply put the water on the sun, it evaporates, and then you remain with your salt down there. So now we are also looking at a special kind of technique that is used to separate special kind of substances that may be mixed together. So for instance, the example that is usually used here is the dyes, like the color dyes. Okay, those are the ones that we use here. Like even the ink in a ball pen, or even sugar dissolves in water, and all those kind of stuff. So that's what we are going to look at under chromatography. So let's talk of a paper. Let's talk of a paper chromatography. So a paper chromatography, we are saying a paper is a medium. So when we say paper chromatography, it means we are going to use the paper as a medium. So we use a paper as a medium. So this paper, we use it as a medium for this technique. Okay, and then the solvent usually that is used here. So this is paper, that's why it's called paper chromatography. Then the solvent, okay, the solvent that is used here is what? Is ethanol. Okay, so ethanol is some kind of an alcohol. Okay, ethanol is some kind of an alcohol. So ethanol is what we use here. Now I'll explain how this works. Okay, I'll explain how this works and how it can be used to do whatever that we want to do. Okay, so let's say we have we are dealing with a paper chromatography. So let's see what we can how this can be demonstrated and how it relates to the question that we have. Mind you, all this background is to help us solve the question that we have. So that's why I'm giving the background so that we can be able to solve the question that we have. So let's say we have something like this. We have something like this. Okay, then we have something like this. Then we have something like this. Something like that. Then here also we have something like that. And then let's say we have, then we have that part also there. Okay, so this is the solvent, and then this we are calling it as the starting line. Okay, I'll explain what that starting line is used for. And then this is the spot, and then this is the cover. Okay, that's a cover, and then this is the solvent front. Solvent front. Okay, so we have from here, this distance here is this distance is the distance that has been moved, that has been covered by the spot. So this is distance traveled by this spot, traveled all the way from here to there. So this is distance traveled by the spot, this spot there. You may still be wondering what that spot is. Then from here to there, this is the distance traveled by the solvent. Okay, by the solvent front. So now what is happening here is, and then I've forgotten this one. We have, this is a filter paper. Then this is the tank. Okay, so what is happening basically here is that this is the whole setup. So we have this tin or a tank, whatever it is. Then inside this tank here, we get the solvent, which we are calling as ethanol. So we put ethanol inside here, okay? And then we get this piece of paper. We get this piece of paper. So on this piece of paper, what we are simply doing is, when we get this piece of paper, then we'll draw this line on a piece of paper. Before you can dip it into this solvent, we'll draw a line here. Now, when you are drawing this starting line here, pay particular attention. You don't use a pen, or you don't use ink. You don't use a pen. That's basically saying you don't use ink. Why? Because when you use ink here, it will disturb your experiment, because even what you are putting here is ink. For instance, here you want to use, we are using dyes, okay, the ink, the color dyes. So when you are using the color dyes, even the ink itself is got some color pigments there, some dyes. So it will disturb the experiment. So instead, what you do here, this line here, the starting line, you draw it with a pencil. So you use a pencil so that there's no confusion with the dyes that you're going, the color dyes that you're going to put there. So you use a pencil to draw the start line. So that part is even examinable. You can be asked as to why you use a pencil to draw the starting line. So the answer is simple. We are simply saying we are avoiding to use color here. Okay, we are avoiding to use ink, because ink is going to be carried by the solvent upwards, so it will disturb the experiment. So pencil doesn't have ink, so pencil is never disturbed by the solvent which we have here. So basically what happens is when you dip this paper into this solvent, the solvent will start flowing into the paper. It will start entering the paper and it will be rising upwards like that. So it will be going upwards. This same solvent here will be going upwards. Okay, Barbara, you're welcome. Yeah. So we're looking at paper chromatography. So we're saying here, the moment you dip this paper into the solvent, which is ethanol in this case, so this ethanol on its own, even if there's nothing written on the paper, it will start moving upwards. It will soak this paper, kind of. It will be soaking this paper. It's like what can I say? When you get even the same paper ingene some cooking oil imabwero yamba ya bulokwera igwera pa paper pa but paper nishi ya perache hapa but the oil start rising going up. So this is what we are talking about here. Even a cloth, water will still rise up the cloth if you do it like that. So this is what we are talking about. So we are saying when you dip it there, now on the start line here we have said you use a pencil so that as this is rising, the solvent, as it is rising, the pencil will not affect the colors and the like. It will pass by the pencil here, it will come very clear the way it is, it will just be rising up like that without any problem. Okay, so then what you do is you put the color pigments here, you put the color pigments there. Now when you put the color pigments here, allow me to use the smaller dots there. So we're saying a dot there and a dot there. Yeah, so you put a lot of colors here. Maybe that's a different color. You get another color depending on what your experiment. So you put those colors. So I put red, blue, red, black, and green. So you put these spots here on the starting line. Now, when you put them on the starting line here, what is going to happen is when you dip this paper into this solvent, the solvent will start rising like I was explaining. As it rises, it will carry along these dyes from these colors. So even these dyes will start rising. They will start rising. They will be going up following the solvent. Okay? They'll be going also following the solvent. As it is rising, they'll also be rising upwards. Okay, so now the one that rises the most, for instance, maybe this one ends here, this one ends there, and then this one ends there. The one that rises most, it means it's more soluble in this solvent. Okay, it's more soluble. That's what it means. When we talk of solubility, we are simply saying chamene chimasunguluka fast. So ni yamene abwera high imasungulika maningi kuchira vinzake hivi. So this one is more soluble. Isungulika fast. That's why ienda fast. Mukafaka pa paper chromatography. That's what happens. So the one that rises fast higher is the one that is more soluble. Meaning the one that would be down here the most is the one which is less soluble or least in terms of solubility. So yamenaenda pamwamba ili more soluble. Then as this solvent is rising, it reaches a point where it ends there. Where it ends, that's where we are saying the solvent front. Ija solvent yamene nzobwera enze kusogolo ija pamene yaperera panja. That's why we are saying solvent front. So this is where it ends there. That's what we are calling as solvent front. Yeah, so the solvent front is here on this line here. That's where the solvent front is. And then we are saying, yeah, from here to here, this is the distance that has been traveled by the dye, okay, or by the spot. So upon zappa, it will just be as clear as possible. The spot will only be where it ends, where it cannot go any further. Then this same color here will come and put a stop there. What's this? A spot. Another color also will rise up until it reaches where it can go further. The spot will be seen there. This one also rises until it reaches where it can go any further. There will be a spot there. So this is what will be recorded on the paper that you are using there on the filter paper. So this is what we have in a nutshell. Now, the other thing you need to observe here is this starting line is way above the level of the solvent. If the level of the solvent will be raised up here, if these colors will be dipped inside, what's this? The colors here, these dyes will just dissolve. They will just dissolve into this solvent. They will not rise up. So that's why it has to be above this level, so that it's this solvent that will enter into the paper and start rising up. So as this solvent is rising up inside this paper, then it will pick along also these color pigments and rise with them as it is rising up. But if this solvent will be above this starting line, it means these colors will just, these color pigments will dissolve into the solvent and they will not rise up. The other thing also we are saying is they have to be very small dots. You just put a dot, pa, pa, pa. Why are we putting small dots? It's because if we are to put a bigger dot, because before it starts going up, it spreads a bit, it sprays a bit like that. So if we are going to use big spots like this, we use big spots everywhere. Even here we use a big spot, and also the other side also we use a big spot. If we were to do that, you realize that as this solvent passes through where these are, these they'll spread and they'll mix up. So it will disturb our experiment. They will end up mixing up because they have to spread a bit on the sides before they can even start rising. So if they are too big like this, then they'll mix up and will not know which color will rise the fastest or the furthest there. And since we are saying the further, the more soluble, okay, and the shorter, the less soluble. So it will be difficult for us to know what we are actually having if that was to be the case. Okay, so I don't know if there is any question on what we have just discussed before we can look at one example. Okay, so the other thing is that you've seen there's a cover here. This thing has to be covered. Okay, because if it, imagine if it was just in an open place, you use as this is rising, the temperature also heat it so much that it starts these color pigments may start evaporating, may be affected. Okay, so it has to be closed up inside a jar or something which we are calling as a tank, so that the atmosphere there, the air there inside is saturated. It will not allow any evaporation of any kind from these dyes until we attain the colors that we want. Now, sometimes you are going to do an experiment like this. Maybe you are going to use some things that are not that are colorless, substances that are colorless here. Maybe you use sugar. Sugar may be colorless, so you want to know how far it has gone and whatever. Like in our question, we have 3 sugars. We don't know what sugars these are, but we have 3 of them. So now, you may not see on the paper to say this one has ended here, this one has ended there. So now what we do is you have to spray what we call as an allocating agent. So you remove this paper and spray what we call as allocating agent. So one of the example of allocating agent is silver nitrate. So when you spray on a colorless sheet like this, it doesn't have any color because the substance you're using are colorless. You spray um, silver nitrate solution on it. So you see that the silver nitrate solution is going to react with the spots, okay, and then those spots will eventually be seen. Tuzaoneka tuma spots, okay, kena angalia hapa, kena angalia hapa, kena angalia hapa, after you have sprayed the silver nitrate. So the silver nitrate is simply an example of a locator. So there are times when you hardly see the spot. You hardly see these spots. When you can't see the spots, you get a locator. So one of the example is silver nitrate is a locator, is an example of a locator. So when you spray it, you spray this paper, you are going to you'll be able to see those spots because it will act with those spots, it will react with those spots, and then they will be spotted, they will be seen to say paja palika spot na paja palika spot. Okay, so that is one thing that we can talk about also. Yeah, that's one thing we needed to talk about as well. Okay, maybe from here we can look at one example, and then from there we can see what can be done next. So you can look at an example that has to do with this, and then see what happens next. So example, please, if you have a question, just simply say what you want to ask. Sir, there I'm not clear, then I'll gladly explain what you may need to know. So simply don't even waste time to raise your hand, because I may not be able to see your hand. So just say, sir, there I have an ask, like others would say. Yeah, so let's look at an example. An example, we have this we have this. Did I even write the question here, or I just have the example? Okay, so I didn't write the question, but I have the graph, the table here, so you can use it to. Okay, so we have black, we have red, we have blue, we have green, we have orange. Okay, so those are colors. We have black. So this is our starting line. Very important, and it always has to be drawn with a pencil. Okay, so starting line there, and then we have these colors now: black, red, blue, green, and orange. They were put in an experiment in a chromatogram. So they were put there, and then we want now to see what happened. So this example I have only has the results. So we have, this is 1 2 3 4. So we have 1 2 3 4. Okay, so we have these spots. Then ready, we have this one here. Then blue, we have that one there. And then green, we have this one here. And then orange, we have this one there. Okay, so now if you check properly here, you see that these are on the same line there, these are on the same line there, these are on the same line there, and that's the line also. If we are to do it also like this, we'll see that we have that, we have that, we have that, we have that. Okay, those lines are not necessary, but I'm just showing to say how we match the levels, to say, okay, this one has gone to that level, same as that one, and so on and so forth. So now, so we see that from here, one thing we need to understand is the spots that travel the same distance, it means they are made up of the same substance. Okay, all the spots that have traveled the same distance, it means they are made up of the same substance. So when you check black here, when you check this black color here, so there was a spot at that point, and also red, traveled up to this point. So it means in black there is red. So black comprises of, so one we have red. So red inapezeka muri black. So we have red. Two. So there's red. What else? Blue. So we see that blue also, black went as far as blue. So meaning mu black there is also blue, because they have risen to the same level. So when they rise to the same level, it means they are made of the same substance. So mu black mwenzeko na blue. This is what it means. So when we come to green, green also is found in black. So it means there's also green in black. And finally, when we see orange, orange rose to this point, and black is also having that point. So you see that in black there's even orange as well. So that's what it means. So all these colors combined together, they give us black. So meaning all those color pigments are found in what? Black. That's what that means. So when the dots are on the same, at the same point, they have risen to the same point. The color pigments here have risen to the same point. Then you know to say, okay, these two are made out of the same substance. So a very quick example that we can use about what we have just learned here about rising to the same distance. Okay. For instance, this same paper chromatography is used to test fake notes. Okay, this same paper chromatograph is used when testing for fake notes. How do you test for a fake note? So those fake notes are put, the colors in both notes are put in the solvent. So when they are put in the solvent, then you notice how far the color in the fake note rises, how far the color in the fake note rises. And you also notice how far the color in the original note rises. If the two are going to be different, then we know that there is a real note and there is an original note and a fake note there. But if they are both the same, they will rise to the same point, the same distance, both of them. So that is how you can use the paper chromatography to test for the identity of notes, the fake, to test to identify the fake notes. So it can also be used in separating pigments from plants. So you get different pigments from plants, you can put them there and then separate them. This one is more solid depending on their solubility. So as we said, the one that rises further, the one that travels the furthest distance is the one that is most soluble. Okay. So it can also be used in identifying flavoring components in foodstuffs. Okay. So those are a few applications that can be used for a paper chromatography. Okay. If there are no questions, let's consider the second example. So this was example number 1. Let's move on to example number 2. This I was just explaining that when they rise to the same level, this is what it means, and also how you can apply this. Like for instance, the example I gave on identifying the fake note. So we move to the next example. So we have a question here. I don't know which paper this question was, I forgot to check. So I'm saying the diagram below, example 2, the diagram below, shows a chromatograph, shows a chromatogram obtained using solutions using solutions of three single dyes. So we have blue, green, and red. And 4 other solutions. 4 other solutions, which are A, B, C, and D. Okay, those are the 4 other solutions. So we have, this is what we have here. So we have the solvent front, and we have the starting line. Okay, so we have red here, we have green, and we have blue here, and we have A, B, C, D. So we have those other solutions, like we have those other colored dyes. Okay, 4 other solutions, A, B, C, and D. So now let me just draw this to my faint lines so that we can at least use them for locating and knowing how far, which ones are on the same line and the like. Yeah. Okay, so we have, those are not necessary, but we are using them just to see which one rises above the other. So the A, we see that it rose to, we have this point here, another point here, and another point there. Then B, it's only here. Then C, it's only there. Then D, we have a spot here and a spot here. Then blue, we have a spot here. Then green, we have a spot here. Red, we have a spot there. Okay, so that's what we have. Now, let's go to our questions. Let's go to our questions. A says, which of the solutions, these solutions A, B, C, D, which of the solutions A, B, C, and D contain the following? So part 1, so these A, B, C, D, these solutions A, B, C, D, which one of these solutions contain the following? So part 1, we are saying which one of these A, B, C, D solutions contain one dye only, contain one dye only. So which one contain one dye only? So between A, B, C, and D, when you look here, which one contains one dye only? Okay. So we see that B contains one dye, there's only one here. And when we look at C also, it only has one there. So B and C, they only have one dye each. So this one has one and this one has one. That's why it has got nothing else. We are only up to that point. So this is a special dye and it rises only to that distance. And this is also a special dye, it rises only to that distance. So B and C contain one dye only. So I'm saying B and C, according to this table that we have, contain B and C contain only one solution. So A contains, one dye. So A contains 1, 2, 3. B has 1, C has 1, D has 1, 2. Okay, so that's what that graph means. So the next question says, part 2 says, so the question is the same. Which of the following solutions A, B, C, D contain the following? So Roman numeral 1, we're saying one dye only, and we have answered as B and C. Then we go to the second part, says 3 of the dyes. 3 of the dyes. So part 2 says 3 of the dyes. So part 2 says which one contains 3 of the dyes? 3 of the dyes. 3 of the dyes. Okay, so the dyes we are talking about are these: blue dye, green dye, and red dye. No, nadayinga CC, nadayinga chani uko, neze nadayinga hapo. Those are the dyes we are talking about. So now we are saying of these solutions A, B, C, D, which solution contains the 3 of the dyes? Contains all these 3. So meaning blue goes to the second line there. So that solution should be on the same line with the blue. And when you look at which one is on the same line with blue, we have B and A. So between B and A, we know there's one which is a solution there, which is the correct answer. Then we go to green. When we go to green, green goes to the first line only. So B doesn't have anything here. So we know it's A that has there. So A already contains blue, which is that one, and green, which is that one. Then we go to red. Red is on the fourth line. So even A has a spot on the fourth line. So we see that A contains all the 3 dyes. Because blue here, it's found. Green here, it's found. Red there, it's found. So A contains all the 3 dyes. So our answer here is A. Among these solutions, A contains all the 3 dyes. Okay. Then the last part says green and red only. Green and red only. So which one contains green and red only? So which one contains green and red only? Okay, so green and red only. If I were to ask anyone to pick it up from there, who can tell us quickly between A, B, C, and D, which solution here contains green and red? Green and red only. Which solution here? Just quickly, anyone? Just within a second. D, correct. So D contains green and red, because when you look at green, it's on the spot is on the first line. D has a spot on the first line, though A also has a spot on the first line. Yes, these two have spots on the first line, but then let's go to red. Red, D has red here and A has red, but A also has this color here, which is blue. So the question simply says green and red only. So green and red, green, red. So green and red only is D. So thank you so much for that answer. This is very much correct. So D is the solution that has green and red. Okay. So which one of the following contain a dye? Let's see who gets this one also. Let's see who gets this one. Let's see who gets this one. So this one says, which of the following solutions A, B, C, D contain the following? Here we're saying a dye, a dye, a dye rather than blue, a dye rather than blue, green, and red. So, which of the solutions here contain a dye rather than blue, green, and red? It contains a dye which is not blue, it's not red, it's not green. So, which one here? Quickly, in a second, which solution? It contains a dye which is not red, which is not blue, not green, not red. Which solution here? Quickly.
C.
Great. I'm only hearing the same voice. Okay, who else? Can I hear a different voice?
It's C.
Great. Thank you so much. Thank you so much. Is that Barbara? Or Chile, she has raised her hand. Are you the one who gave us that answer?
Yes.
Perfect. So C, when you look at C, there is no any other dye that is matching from blue, green, and red. It's just alone there. Blue is nowhere. Green is nowhere. Red is nowhere. So it's an independent solution. It doesn't have any of these dyes. So yeah, that's what we have there. Okay. Let's go to B. Let's go to B. So B has got things that we are just from talking about. I'll rub everything since this was A. So now we're going to B. B doesn't have much to do with this graph here, but we can make reference, or let me just write it above the diagram here. So B says, B, in preparing the chromatogram, the following instructions are given. The following instructions are given. Okay, suggest a reason for each. So suggest a reason for each. Okay, so now here are the following instructions that are given, and we need to suggest a reason for each instruction. Why is this instruction given? Yeah, because these instructions are given. Now we need to suggest the reasons why. So number one instruction, we have the start line. The start line should be drawn with pencil. Someone is trying to say something. Okay, so we have that first, that one of the instructions before you work out this chromatogram is that the starting line, this one here, should be drawn with pencil, not ink. Can someone just quickly, from what we have learned, explain even whatever they have heard, whatever they have gotten? Why should we use a pencil here, not ink? Just quickly, let me point. Barbara, Though you came late, I don't know if you got what we were discussing earlier. Are you able to explain why we're using a pencil here? Let's just interact a bit. Okay. Okay. Mlenga, you can help out. Ladies first.
Um, Menga here.
Yes.
Hello?
Yes, I'm getting you.
Sir, are you getting me?
Too much.
Yes, please.
Oh, okay. Barbara is
Yes,
back.
I'm
Yes,
saying that.
Barbara, go ahead.
Yes, sir. Uh, we are using a pencil so that if any means we make any errors, we are able to cancel.
Ah, great.
Is
Great.
it?
Great. Okay. Mlenga, can you say something as well?
Okay, we're using a pencil so that in case as the solvent will be going up,
Mm-hmm.
it does not get like do not get wrong readings or the ink does not disturb the solvent as it is going up.
Wow. Okay. Does anyone feel they have to add anything, or we can move on with the answers that have been given?
Uh,
The gentleman?
yes, sir.
Yes.
Yes, sir.
Yes, Barbara, go ahead.
Hello?
Yes, I'm getting you.
I think, yes. I think also is that if we were to use a pen or an ink, it
Mm-hmm.
may disturb the solutions that are inside there. I think that's my suggestion for now.
Okay.
So
Can you
because we are
explain
looking
further
at
how it can disturb the solutions? Are you able to explain further how it can disturb the solution?
of course, yes,
Please go ahead.
it can disturb the solution in such a way that it may have the blue color, which is not supposed to be there. I don't something like that.
Okay. So I'm sure we all get the whole idea, isn't it? So we are using the pencil here because these are colors. These are color pigments or like the dyes. So imagine if this line also was in ink, it had ink. As these dyes are rising up, this whole line will rise. The whole line will be rising together as the solvent is going up. So it will distort the whole thing that we are doing here. So we use a pencil like you have said. So because the pencil will not react with the solvent, it will remain as a line just like that. Nothing is going to rise from the pencil. Only the dyes that we put there, the colors that we put are the ones that are going to rise up. Is that okay?
Okay, sir.
Yes, yes. Actually, you came a bit late. I don't know if you were together on that part. Let's go to the next instruction. Let's go to the next instruction.
Okay.
So the next instruction says um, the sports the sports the sports the sports on the starting line must be small. Okay, so the spots on the starting line must be small. So quickly, let's check out that one. Why are we saying the spots here should be small on the starting line? Anyone to quickly? Now let's have yes, Lumba. Let's have Lumba say something as well. Why should the spots be small?
Because when the spots are rising up, they because since they're big, they can get mixed up. So we have to make them small. So
Great. Does anyone has anything to add on or subtract from what Lumba has said? Okay, so basically what Lumba has said, I'm sure everyone else can confirm. They should be as small as possible so that they just rise within that path there. Because if they are big, they'll spread and then they'll mix up and then the results will be distorted. So that's why they have to be as small as possible. Okay, so this is where we end from what I prepared for today. I do believe that whatever we have discussed is able to make us understand and answer the question that we have in the paper. And looking at time, we have, this is 1927. We only have 3 minutes to the end of this class. So I was hoping that you try the question in the paper and send the solution, so that I'm also able to confirm that what we have learned, you have really understood. And on the other hand, also just to give you enough confidence to say, okay, now you are able to answer that question by yourself after we have learned. I don't know if everyone buys to that idea. Can I get your feedback?
It's okay. But what time are we supposed to submit the
Anytime you finish at 01, you can send. I'll see it in the morning. Whatever time you finish, just send, then I'll check it later on. Please bear with me if I don't respond on time. Yeah, it means I was just held up and I was busy. I've seen the solutions for mathematics. And let me caution also, please don't send in the group, because everyone will see your answers and then it's distorting the whole purpose of an exercise. Send in my inbox so that I check your work alone. Don't give the solutions to everyone. It will be in this class where we can meet with everyone to say, okay, there I had a problem, let's work it out. So don't post the solutions in the group, because everyone will get the solutions there. And then there's nothing we would have done. So you send the solutions to my inbox at any time you finish. Then I'll check them when I have time and respond. Is that okay?
excuse me, sir.
Yes.
I was kindly asking, this question, we're finding it in the question paper that you sent?
Yes. It's B2. B2 of the paper that I sent.
Okay, then thank you.
Yeah. If in case you don't find it, let me know. I can forward it again. Section B. We are dealing with section B questions, not section A. We're not dealing with multiple choice. We are dealing with the essay form questions, because those are the ones that have got more marks, and because we need to learn those topics now. Okay, so if there's nothing else to discuss, I think we can have our class dismissed, unless there's anything else to say. Okay, bye-bye. Let's meet tomorrow, same time for biology, those that are doing biology. Same place. Thank you so much for your time, and invite your friends. One more thing before you go. Yeah, I need to emphasize on this one. So what we are doing is that when you bring a student, you bring one student, they register, they pay, then you have a discount. Yeah, so per student you bring, they register, you have a certain discount. We agree how much we can reduce from how much you are paying. So the more students you bring, eventually you may only remain with 100 kwacha to pay, or nothing at all in that particular month. So this should run every month. So you bring a friend, yeah, let that friend mention to say, oh, this one told me about this. Then what we'll do is, okay, we'll have to put a deduction to you. Yeah, something like even a 50 kwacha or so. We'll agree on how much we can deduct from your payment. Thank you so much otherwise, and enjoy your evening.